So on the left, I have sets in set builder notation, and on the right is the corresponding interval notation. Now remember I said if it's a parentheses or an open bracket, in other words, it's rounded like this, you don't include the endpoints. But with the square brackets, you do include the endpoints. So let me just write that down so you have that in your notes. So here we include endpoints. And here we do not include endpoints. All right. So let's look at these examples. Notice that -1 is less than or equal to x, which is less than or equal to 6. So we're including -1 and 6 because these little lines underneath here mean equal. So x could be equal to -1 or 6. So that's why we've used the square brackets. In part B, -1 is strictly less than x. There's no equality there, so we use the open bracket. But for 6, we do have an equal sign, so we use the closed bracket, the square bracket here. And here it's just the opposite. The -1 is included, but the 6 is not, so we write it like this. And of course, this just shows everything in between. Now you'll notice this representation is an interval. -1 is less than x, which is less than 6. So x is between -1 and 6, not including -1, not including 6. This looks like a point, right? It's not a point, it's an interval. And how do you know the difference? Well, simply by context. The context of your problem. If you're looking for an interval, then you know that's an interval. If you're looking for a point, well, then you know that's a point. So it's just something to be aware of. In parts E and F, notice we have or and. So let me talk about the difference between those two. If you say that x is less than -1, or it could be between 3 and 6, including 3 and 6, it could be an either interval, this one or this one. So you have to include both as a possibility for x. Here, however, it says and. That means x has to satisfy both of these criteria here. So what you do, if you want to sort that out, the best way is to graph it like I did here on the number line. Notice I have from 2 to 7, and then overlapping I have from 4 to 8. It has to be in both sets, which means it has to be in the overlapping part. So from 4 to 7, including 4, but not including 7. So I've written it here like that. So that's how you deal with the and. And finally, with these last 4, these are sets that involve infinity. So if x is less than 5, as it is here in G, it's not including 5, so I use the open bracket. And of course, the infinities always have the open bracket. Here the 5 is included. X is less than or equal to 5, so I have from -infinity to 5 with the square bracket. Here x is greater than 5, so I'm going from 5 to infinity with the open bracket. And here it's greater than or equal, so I have the square bracket. If you have trouble knowing how to write that, just use a graph. So if you look at G and you want to graph it, it says that x is less than 5. So if you mark 5 and you're not going to include 5, but it's less than 5, that means it's on the left, right? So you're going to write it like this. And so it's from -infinity to 5, and that's how. So these intervals really match the way you graph them. So some people are more visual and they like to have a graph. So if that's you, you can use that as an aid when you're trying to figure out what the interval notation is. But both of these notations, set builder, which is the left-hand side here, and interval notation, they're used interchangeably all through our course. So you want to be comfortable with both of them. And that concludes